Welcome to The Explainer. Today, we're diving into a really short, but honestly, pretty profound piece of text. It's one that completely forces us to question the actual fabric of reality. You know that concept we all think we've got a handle on? Quantum mechanics? Well, this flips the mirror right back onto us. We're going to deeply explore how science actually operates, how we perceive the universe, and ask a really uncomfortable question. Are our own tools subtly tricking us? Think for a second about how we currently understand the universe. We measure it, right? We map it, we calculate it. But I want you to really consider the opening premise of our source text today. It asks this deeply Socratic question. What if measuring things with all our fancy scientific apparatuses isn't actually giving us the absolute truth? What if it's just a highly specific perspective on reality? Think about that. Are we seeing the whole picture, or just the tiny, fractured little slice that our tools allow us to see? Look, if you stare at the night sky through a red lens, everything looks red. The universe isn't red, your lens is. Keep that idea in the back of your mind as we go. Section 1, the obsession with measurement, and how we check our theories. So the text states the foundation of modern science pretty plainly. It says, measuring systems are the absolute most important thing to get our theories checked. And yeah, that is the bedrock of how we operate, right? We come up with a theory, we build some highly complex machine, we take a measurement, and boom, we validate our ideas. We rely entirely on these specific tools to confirm what we think we know. But the source material is warning us here. It warns against anchoring our entire understanding of reality to just these systems. Think about how inherently we trust a simple ruler in our hands. We measure something, we trust the number. We almost never stop to ask, hey, is this ruler somehow changing the object it's measuring? Is it totally inadequate for the job? By blindly trusting the apparatus, the text suggests we might be setting ourselves up for a massive philosophical blind spot. Basically, we end up mistaking the measurement for the reality itself. Which brings us to Section 2, the scale of quantum behavior, and a very strange anomaly. The text defines quantum mechanical behavior by highlighting this glaring, almost ridiculous discrepancy in how things act in our universe. It points out that the tiny, small objects we identify behave completely differently from objects that are much, much bigger. Imagine throwing a baseball. You know exactly where it is, you know how fast it's going. That's our normal macroscopic reality. But now, shrink that baseball down to the size of an electron. Suddenly, it's not a solid ball anymore. It's this blurry cloud of probabilities. It might literally be in two places at once. It exhibits incredibly strange behavior that completely defies everyday logic. But massive things, like that original baseball, they generally do not act this way. So this definition from the author focuses purely on that fundamental, jarring clash between the microscopic rules and the macroscopic rules. It's honestly like the universe is playing by two completely different rulebooks, just depending on how zoomed in you are. The author then methodically steps through a progression of scale to show just how unstable this dual rulebook idea really is. First, like we just said, small identified objects behave differently than bigger ones, okay? Second, pure logic dictates that somewhere in between, things must change, right? There has to be a border where the weird quantum stuff stops and normal behavior begins. But here is the massive fundamental revelation the text throws at us in Step 3. We have already seen some systems behave quantum mechanically at sizes as large as us. The boundary isn't just neatly tucked away down at the microscopic level anymore. And that is a staggering concept. It means the strange, totally unpredictable rules of quantum mechanics can actually scale up. If human-sized systems can exhibit this behavior, well, it completely destroys the comforting thought that quantum weirdness is safely contained to atoms and subatomic particles. The weirdness is bleeding into our scale. So, because this quantum behavior is inexplicably creeping into human-sized systems, the author forces us into a massive philosophical dilemma. Is reality itself fundamentally quantum mechanical? Or, and really think about this, is it possible that the way we divide reality up actually creates quantum mechanics? This is the ultimate binary question. We're being funneled directly into a massive paradigm shift here. Are we observing the rules of the universe, or are we literally inventing them based on how we choose to chop the universe into pieces? Let's look at Section 3, Possibility 1, Quantum Reality. This represents the standard, widely accepted view of the modern scientific community. The text frames it right out of the gate. In the first case, reality is obviously quantum mechanical, along with its strange interpretation. Basically, when faced with the absolute paradoxes of physics, we typically just accept the inherent weirdness of the universe. The scientific community kind of gives a collective shrug. We say, well, the universe is just strange at its core, and our measurements are just correctly showing us that bizarre reality. We assume the universe is a weird place and our tools are just accurately reporting the news. We don't question the camera, we just marvel at the strange picture it takes. But then we have Section 4, Possibility 2, Dividing Reality. This is where the theories diverge in such a fascinating way. The first path assumes the universe is inherently weird. The second path, though, it shifts the focus entirely back to us, the observers. What if our arbitrary divisions create a quantum illusion? What if the universe isn't actually fractured into these bizarre quantum states, but rather our attempt to chop it up, isolate it, and measure it is the very thing causing the weirdness? Imagine taking a beautiful, seamless, continuous painting and forcing it into tiny, rigid digital pixels, and then wondering why the edges look so blocky and unnatural. The painting isn't blocky. Our method of dividing it is. I want to pause deliberately on a truly monumental quote from the text. In this second scenario, quote, "We just take the blame of dividing reality in a way that it is not divided, and this results in strange behavior we think exists in the divisions we have made up." I mean, that is huge. The strange behavior might not belong to the universe at all. It might simply exist within the artificial boundaries that our own minds and measuring tools have forced onto a seamless reality. We are taking the blame. Think of the universe like a completely unsliced cake. It's whole, it's unified, it acts as one continuous thing. But to understand it, science brings a knife. We slice out a piece, an electron, a photon, and we completely separate it from the whole. When that single slice starts acting strangely in total isolation, we blame the universe. But the source suggests the act of slicing itself created edges that were never originally there. The weirdness is just an artifact of our end tools. Moving to Section 5, Investigating Both Paths. So, what exactly is next? The text breaks out a very clear, defining call to action for us. Our current tendency in science is to just blindly assume reality is quantum mechanical. Honestly, we prefer to think the universe is chaotic rather than admit our methods might actually be flawed. But the alternative is incredibly compelling. We have to deeply consider that our own divisions are to blame for the strange behavior we observe. Therefore, the necessary next step, according to the author, is that we absolutely must investigate both possibilities with equal rigor. We can't just default to the one that says reality is inherently weird. Doing this requires a massive ego check for modern science. It asks us to step back and admit that our most advanced, precise, billion-dollar instruments might actually be generating the very illusions we're trying to study. We have to be radically open to the idea that the flaw is in our lens, not the landscape itself. Which brings us to the end of today's explainer. I want to leave you with one final, lingering, and honestly provocative thought. Are the strange behaviors we observe in the universe actually real, or are they just divisions we completely made up? The next time you read a headline about some bizarre, inexplicable scientific discovery, stop and ask yourself, are we finally seeing the universe for what it truly is, or are we just looking at the cracks in our own ruler? Thanks so much for joining me on this journey through reality and perspective.